If you've ever purchased a piece of HP test equipment from the 1960s and had a hard time finding a power cord for it, this video is for you. So in the 1960s, HP used this connector called the PH163 on much of their test equipment. And the PH163 cord, if you've tried to find one, you'll see they're very expensive to buy. You can't buy them new anymore. You can only get used or new old stock ones on eBay. They go for $50 to $60. And we're going to talk about the alternatives here. So I saw someone ask a week or two ago in a Facebook group why HP had to use this connector and didn't use the standard IEC 320 style connector that you're familiar with computer equipment and modern test equipment. And the answer to that is because the IEC 320 standard wasn't introduced until 1970, and then it took a few years for the manufacturers to catch on. So if you have a piece of test equipment that was introduced in the 60s and was made by HP and a few other brands like this Kepco power supply uses it, you'll find this PH163 connector. There are some alternatives though, and we'll talk about them in this video. So the first thing that would come to mind is removing the PH163 male receptacle on the unit and just replacing it with an IEC 320 style. I think C14 is the inlet here. And sometimes you can do that. Sometimes you just got to grind a little bit of metal away and you can just install this and be on your way. But that's not always the case, and these three pieces of equipment show why. So let me turn around the 651A. So if you look at the back of the 651A, the inlet's over here on the left. Let me move the camera a little. And what you see is it's riveted in and there's not much room around it. If you hold up the C14 connector here, it looks like it would fit, but let's open this up and take a look at the inside and see why that'd be a little more challenging than it looks. So here's a look at the inside of the 651A, and you can see what the problem is here is that there's a line filter built into the back of the socket. Let me see if I can take this out, this cover. I did this once before. There we go. So you can see that there's some components built in there. Now, you could likely hog out some metal and make something work. The other thing that you could do is you could just drill a hole here and you could, sorry, I'm zoomed in a bit much. You could just drill a hole there and use a Hayco bushing and run a power cord through and connect it here. The other thing you could do is eliminate all of this stuff and install a module, a modern line filter module. You could find one with similar specs to whatever HP used here. But that's a lot of work and it's money. Those line filters cost at least $10, up to like $30, and you'd be having to grind with a Dremel or something and you'll be getting dust everywhere. So that's not ideal. And you'll see the same thing on the other two devices I have on the bench here. Let me show you those. Okay, so then we'll look at the back of the 3400A and this Kepco power supply. So you see with the 3400A, it's pretty tight to the bottom of the chassis there. There's also a voltage selector switch above it. So if you were to do this, you'd again have to grind it out, and you'd have to make the holes, you'd have to move the holes up a bit higher, and you'd potentially have to find something to replace that voltage selector switch. Now they do make these inlets with a voltage selector on them, but there's also limited depth inside, so it's not ideal to have to do this. And of course you got to grind it and get dust everywhere. And the Kepco power supply, same thing. You just would have to grind that out to a square. This one actually looks like it would, the holes pretty much line up, so it wouldn't be too bad. But again, grinding involved, not ideal. So what are your options? Well, you can again buy a used power cord on eBay. Now there's a few different styles of these. I don't have the old one anymore, but this is a more modern style. It's like a PVC type cord, like you would expect out of a normal power cord. But there were some older ones that used an older type of insulation, different older type of rubber or something, and I had one that was all cracked, and it was not a healthy looking cord, so I wouldn't recommend using those. They come in gray and black. This one has a Belden part number on the, well, not a part number, but it just has a Belden logo on the end here, and it says 7 amps, 125 volts. Now one thing to know about the PH163 is depending on, there's two variants of it. There's the one that HP and some other companies use, and there's another one, I think it's like a UL standard, where the ground is always the center, but the hot and neutral are switched on the other one, so you got to make sure to get the right type of cable. And I'll put a link in the description to a page that describes the history of this and the different pinouts. Then the other option is someone generously created a 3D model and shared it on the internet, so you can essentially sacrifice a regular computer style power cord and you can cut the end off and you can 3D print this connector, and the terminals for it you can get from DigiKey or Mouser. They're a standard part number, and this is a pretty cool option. So I'm going to show you on the screen what his page looks like. Okay, so this is available on Thingiverse, and I'm not going to take mine apart because I already built it and it's all together, but I'll show you his pictures. So here's a picture of it from the end. Here's a picture of it from the top. You can see it's two pieces that you print and then they screw together. And here's how you have to prepare the cable. So you basically just put a rubber grommet around it, and you cut the wires to about this length. You'll kind of figure it out as you go. I don't know he might actually specify the exact length, but then you crimp these connectors on, and you essentially just set them into the recesses on the connector, and then you screw the two halves together, and that's your power connector. You can see there's a little grippy part there, which is a nice touch to prevent it from pulling out when you remove it. There's two versions of this that he made. There's a regular length one, and then there was a longer length one. I've only used the regular length one so far, but apparently some people said they needed a longer one, so he uploaded the model for that. But if you go here, there's the warning. Old electrical devices should not be left unattended, even when they seem powered off. A lot of these things have an oven in them that runs, so the line voltage is always on. So this is at your own risk. They're obviously not UL rated or anything like that. So if you're not comfortable with it, then don't use it. You should probably get it made out of something like nylon instead of PLA if you can. But that's pretty much all there is to it. Here's the instructions. You can salvage your connector. There they are, the TE connectivity 63381-1 female crimp receptacles. So yeah, it's pretty easy. I made one of these. It worked great. And then I later came across a whole bunch of original PH163 connectors, so I've been using those, but I still have this in case I need another one. So yeah, hopefully that'll save you $50, $60 on a cable and give you a much cleaner result than hacking up your test equipment. So I hope this video helped, and thanks again to CYUL for sharing this connector.